So last time we left off having 200 people or circles bouncing around our screen, and we're building up towards infecting them. Just before we went any further, I want to introduce some sort of controls to the screen, making sure it's a bit more controllable by us, making sure that we can change some parameters, etc., without having to go into the code every time. For starters today, just want to include buttons to play and pause the simulation, maybe reset the simulation. So that if I just press start, I don't have the simulation just instantly going. So I'm going to go back into the form design. And we're going to include some extra bits. So a toolbox. If you don't see the toolbox, just click on View and then Toolbox, or you can use the shortcut Control Alt and X, and the toolbox should appear. Other things to note: if you don't actually have the form selected, you won't actually see anything in the toolbox. There are no usable controls, so that's when I've clicked on the person. Selected the form toolbox, I get the things it can do, and you can search through. So we're going to add a button. It's going to be like play pause button, and we want to change the properties about this button. Play/pause. I'll play/pause. I'm going to change the name of it as well, so it's a more useful name. Play. Getting rid of any vowels. Pause. BTN, so I know it's a button. Play, pause, BTN. And what else I'm going to do is going to have my timer, change the properties of the timer so it's not enabled at the start. So now my simulation won't start running. Previously it would have started running because the timer was enabled, so it was ticking. It was ticking away, and it was going and moving the people, invalidating the form, causing the paintball subroutine to be running again and again and again. So this time we shouldn't be getting to the ticking part because the timer is no longer enabled. So what we should see is we've put our new button on the form, but nothing should appear. So slightly different to what I just said. Some do appear because once the form is initially drawn, it does call the paintball function, so they all do get painted initially. And we can see a bit of an issue ahead that we have to think of because some of these people are already touching the zone over here. There's already a lot of people that if one of those was infected, they all would be immediately infected on the next round. There's some more down here and some more down here, so that's something we're going to have to look at this episode as well, make sure that doesn't happen. As for play and pause, currently when we click on it, it doesn't do anything. Nothing is done there. So let's do that next. So we can get onto the event that happens when we click on the play pause button. So I'll show you. We could double click it. I want to show you where the events happen. So on the properties window, when we've got the play pause button selected, we can view events or properties. Properties we just changed a moment ago, to change text to say play pause, to change the name of the button to say play pause button. And we can go for events, and there's loads of different events we could do. Things like when we hover over the mouse, drag and drop things, key presses, etc. And we're going to go for click. So if we double click on one of these, it automatically generates for us a subroutine that will happen when we click on that button. And the play and pause is just going to be about turning the timer on and off, or enabling the timer and disabling the timer. Now we kept timer 1 called timer 1, timer 1 dot enabled. If we set timer 1 dot enabled equal to not timer 1 dot enabled, then whatever state timer 1 is in currently, we're going to not it. So if timer 1 was enabled false, which it is to begin with, not false is true, and I set timer enabled equal to true. So this time when I run it, again we should see the people just stationary, that we've declared them, we've created instances of them, they appear in random locations. Some of them will still be touching each other initially, but they won't be moving around because our timer's not ticking. Then if we press our play button, hopefully it should enable the timer, and then they should stop moving around and redrawing. And they do. And we can keep pressing pause and it disables the timer, enable the timer, disable the timer. And it keeps on doing that. Success. Just load it up one more time and we can see those collisions in the start. Yeah, so we've got some people, some circles here that are already touching. Okay, I'm going to include a couple more things to my form. I'm going to include a forgot the name of it, so I'm just going to have to find it. Common controls. I think it's a slider I'm after. Nope. I'll just keep looking. So all Windows controls. Track bar. That's what I'm after. So I'm after something that will drag to the left and the right to enable me to choose how many people we're starting with. So next I'm going to include a kind of reset button and going to be able to change the amount of people that we have. So I'm going to drag the track bar on. There we get a nice little thing that we should be able to drag from left to right. And let's see what properties we can go for and change. So I'm going to call it person count, then track bar. So I know it's a track bar. What else can I change about it? So I want a small change to be 1, large change can be 5, so I think that'll be flicking between the different ones, and I can set a maximum. So I'll set a maximum of 500 and a minimum of 1. Is there any way to display what number it's on? It's where trying the stuff out before recording would have been good. Take frequency 0, orientation. Visible, true. So I don't think there is. So I might want to make a little label that goes next to this to indicate what number I've actually selected. Let's have a look at what the value currently is. So the value starts at 1. I want to start at something like 200. And you notice there that the arrow's moved up to about the 200 mark. In fact, if we go for 250, then it'll be directly halfway. It's 250 there. You can also include a label, so I get to see what number is being selected. So I'll put it halfway. Might redesign this later on. Again, change the properties. Set it to initially say 250. And set the name of it, so in the code later on I can come back to it. Person count LBL for label. And I'll just pop it there. Again, go and look at the events for when I change the value of this track bar. So value changed, double click, and it'll make me a subroutine which executes when I change the value of the track bar. And what I'm going to do is change the person label text equal to that value that we've just changed. Person track bar dot value. Can we do that? Can't convert into string. So at the end of this, just toString. The value is going to give us an integer number, and toString is just going to change it into a string, ready to put it into our text, our label. So we'll see what happens when we do that. So we should still have our people appear. We'll have our track bar appear there, and when I move the track bar, the label should change to indicate what value I've set it to. The lowest value I remember setting down as 1, and the highest value is 500, so we should see that happen. 1 all the way up to 500. So a little track bar moves backwards and forwards there, changing the label. So once I've selected and changed those, I want to be able to press reset. So I'm going to need a button in a second, and it'll go to that amount of people, hopefully. So next up, I'm going to have a reset button. So I'm going to copy the play pause button because I like the style and shape and size, and change its properties. It's renamed it to being button 1 now, and I don't want it to be doing play pause when I press on it. It's going to be called reset. So change the text to reset, and I'm going to change its name to reset BTN. Reset BTN. The properties, I'm going to change it so when it clicks, double click on it, it creates the subroutine reset button for when I press on it, and the reset button is going to have to redeclare the people in my array create new instances of them again. So it's going to be doing this highlighted bit of code and this for loop again. So in order to cut down on the amount of code I've got, I'm going to make a new subroutine, reset, public void reset, and that's where I'm going to apologies. It's where I'm going to change this value equal to the person count trackbar.value, and I'm going to have the for loop that goes and makes an instance of this in here. And when the form is constructed, have it so it calls this reset subroutine that I've done. So when the form initially starts, it will go and perform a reset, taking the value of the trackbar, creating an array of that many people, then a for loop to go through and making that many instances of people. So I now no longer need this initial one. It's all going to be based off the trackbar. And when I press the reset button, I want to do the same thing. So I can just call reset. So this time, run it. And we'll still get people appearing. In fact, we should have 250 of them appearing, because that's what the trackbar is by default. Some of them are hidden behind these controls. We could do something about that later on. And if I press reset, well, we don't get it redrawn, so that's something we could do. At the end of the reset, we could invalidate, just to force it to redraw, because we didn't actually see any changes there. Invalidate. So when I press the reset button now, it goes to the subroutine reset, goes and makes a new instance of the array with whatever value we've got selected on the trackbar. Going to make those new instances of people, and then invalidate will force the form to redraw, and the form redrawing calls paintball. So this time we'll press it, and we should see the people appear in different places because they're randomly chosen, pseudo randomly chosen. So here we have the form. If I press reset, we're getting those people appearing in different locations. We'll take this trackbar down to 1. We've just got the one person jumping around. 16, sorry. 16. All the way up to 500. Okay, and we can see the difference there. We'll go for 50. Ooh, 45 instead. You can see them there. We still have that problem of the overlapping, which we'll solve now, but that kind of works, and it will work with the play pause button as well. In fact, I think we would be able to reset and it would keep playing. Things we could do about that: we could force that every time we press the reset button, we could force the timer to be false, but we can leave it for now. Yeah, and we've still got those problems of them drawing over the top of each other. Okay. So that's what we're going to do next. And we're going to make sure that these people can't draw over the top of each other. Therefore, when we come to have the infection, we're not going to say this one was infected, it's not going to instantly infect the other two. Same here, this one, this one, this one. We're going to make sure that they are a distance apart. It's obviously going to be more collisions with 500. Yeah, you can see whole regions here where they're all touching each other already. So we're going to prevent that. And the way we're going to do that is kind of going to detect if they have collided. And because this is people, it would make sense to do it in the person class. So we're going over to the person class here. And we're going to have a subroutine called detect collision. And it's going to return to us a Boolean value if a collision has been detected. So it's going to be a function. Detect collision. And in order to detect a collision, this person is going to have to see another person. So we're going to pass through person, because we're going to be comparing one person to another to see if they have collided. I'm going to have a double for distance, because it's the distance that's going to tell us whether they've collided. Because these are all circles, if the distance between them is worth 2 radiuses or 1 diameter, that means that they're going to have collided. So set distance equal to, I'm going to make a subroutine called get distance. Again, passing in person. Now it's going to come up with a red line for us because, well, that subroutine doesn't exist yet. But again, we can make Visual Studio help us, and we can get it to generate the person get distance method. Because we want to try and break down a lot of these subroutines into smaller parts to make them more manageable. So get distance will return to us the distance as a double, just for some accuracy. And then if the distance, if I try and spell it right, if the distance is less than a diameter, so because our circles are all the same size, we've got height and width, so it doesn't matter which one we use. That's going to be our diameter. So I'll just use width. If the distance is less than the width, then the collision has occurred, so we're going to return true. Anything else, return false. Right, getting distance. How do we get distance? Well, we're going to be using Pythagoras to help us do that. So we're going to be taking the square root of the x of one of the circles, the people, minus the x of the other squared, plus the y of one of the circles of people, plus the y of, or minus the y of the other, squared, and then all square rooted. So in C#, we've got some math libraries to help us. So math square root, and then inside of here, math.pow to raise a certain number to the power. So it's going to be getting the center, and we need the center of the circle, I've just realized, so we're going to have to make another subroutine in order to get the center of these people, these circles, because at the moment we've stored the x and the y, and that's the x and y point at which the circle will draw at. So it'll draw at the top left. I think we described in another video, everything is drawn from the top left. So that's the top left of our circle, and then the height and the width kind of make a square that we fill a circle inside of. So we want to be able to get this center of the circle. So I'm just going to make another subroutine to get the center of the circle here, and we'll have it as a float. Get center x. So we'll get the x position of the center, and just because we want to be a bit more accurate with this stuff in the future, I think integers might be a bit they won't be accurate enough for our needs, so I'm going to change them all to floats. Okay, so changed all of those attributes to floats. I think I mentioned that we would have done that later on anyway, but we'll do it now. So we've changed all of the attributes here that were integers to being a float. So we're going to get the x, which is going to be the x position of the top left plus half the width, plus half the width. And a very similar thing for y. Remembering to rename everything correctly. And just for good practice, using height, even though the width and the height are the same. Just see if we can see what that all means. So when we have our two circles, we're trying to get the center locations and then work out how far they are away from each other. So try and draw it a bit bigger. So circle 1, circle 2, or our supposed people. We need to get these x locations, these middle points, and then we're trying to work out what the distance is. And we're doing Pythagoras to enable us to do that. So you can see in this example, they would not be colliding because this value is greater than 2 lots of the radius, or a single diameter. In this example, center x, center y. This distance now, this distance from the two centers, is going to be less than 2 lots of the radius or 1 diameter. Therefore, those two would be classed as colliding. They've collided. There is a gap. There is a overlap between them. So we wanted to work out the difference in those, the distance there, and to see if the people, the circles, have collided or not. Just to make sure that we're okay with this center aspect. So I said that our circles would be drawing kind of in a box. So excuse my terrible drawing. So the x and y position that we store at the moment, the x and the y is the top left corner, and then we've got the width and the height. So the width across and the height. So in order to get the center x and the center y, well, it's going to be the top left corner, which is whatever x is, plus half of the width. And then for the y, very similar thing. So whatever y is plus half of the height is going to get us our center point. So that's what those two subroutines or methods are going to be doing for us. So now we can finally get back to our Pythagoras. So we're looking for the square root of the center x, the subroutine we've just made. There it is. So the center x minus the person that we're checking up against, so the person that we're sending through to check against, dot get center x. So we're getting their x position, subtracting them, and then raising to the power 2. So math.pow, one value raised to the power of another. And we're going to have a very similar thing for y. So we want to add that value add the x to the y. So getting center y of this particular person versus center y of the person that we're checking up against, both raised to the power, and then square rooted, which will get us the distance between those 2 points. And we place this distance in this variable distance, and if it's less than the width, then, in fact, less than or equal to the width, then they are touching. Anything else, they're not touching. So we enable ourselves to detect collision there. We should be able to detect whether they're collided or not. And then when we do our reset, which we did a few moments ago, we can make sure that we only create a person in a new slot, or making sure that we create our new person and they don't overlap, because we can use this detect collision subroutine, and if that comes back true when we compare the new person that we've made versus any of the other people, then that person is made in the wrong place because they're already overlapping. So the way that we can check for this is we want to keep making this new person whilst they are not placed. So bool person placed equals false. So we're going to have a while loop in here. While not person placed. We're going to say, we're going to declare that instance of a person and put it into the array, even if they are overlapping at this point. Say that we've placed the person. Person placed equals true. And then we're going to check against all the other people we've made so far. So remember that this for loop is going and making for every single person. So we want to check all the people before this one to make sure that we've not collided with them, that we've not placed them over the top of each other. So we're going to have a for loop that'll go through, and I'll call this one J, it's variable J, all the ones before this one. So we're going to do less than I, so it's going to go for everything less than I. So the very first one that executes, I is 0, person placed is false, whilst person not placed, it will place the person, make an instance of person, person placed will become true, and it won't do this for loop because J would be 0 and I would be 0, and 0 is not less than 0, so it doesn't check anything there. So then it'd go through and I would be 1 next time, and then it'd place the person, and then in this for loop we need to check everything before this person. So I would be 1 this time, and then yes, there'd be one person to check. When we get 50 people in, I would be 49, or moving up to the 50th, 50. We'd place the person, and then this for loop would check everything before then. So check J from 0 all the way up to less than 49 or less than 50. So in here, this is where we want to use our new subroutine that we made to check whether a collision had occurred. And we want to look at the person that we've just tried to add. So person in the array at position I, do they detect a collision with any of the people in the array before this? So again, we use the arrays people, this time using the value j to access a different person. So we check in the very first person, the second person, the third person, all against this new person. If that detect collision comes back true, then they've collided. So we're going to set person placed equal to false, because we can't have placed them, or we don't want to have placed them, because they are overlapping with somebody else, and we don't need to check whether they go over the top of multiple people. So we can kind of stop this for loop. We can break out of it because we don't need to check against the rest. We're not placing that person because they're over the top of somebody else. However, if we get through this whole for loop and we've not done that one, then this while loop ends because the person must have been placed, and then we go on to placing the next person along. So before, when we ran this sort of thing, we had some overlap between our people, our circles. So hopefully this time we should see that we don't get any overlap between there. And because I changed the floats, I've changed attributes from integer to float, I do have some issues down here. So the form width can't convert from float to int. So my width now I had as being a float. So if I just cast it to an integer, that will fix that. And then the same with the height. And that's because earlier we changed the attributes to become floats, and when we're using a random number generator, it's accepting of 2 integers for arguments there. And by having one of them as a float, it would change it to being a float, not an integer. And anywhere else, and it exists elsewhere as well. And we want this new ball to be a float as well. Float. Just to be more accurate when we're doing our calculations. So that's from changes that we made earlier. And then we'll run it and hopefully see that these people do not overlap. Have a quick look here. Can't see any. Can see some that are pretty close, but it looks like there's something between them. So if we up our numbers to 500, yeah, you can see that there's no, unlike before, there's not any 2 circles, any 2 people that are overlapping, even when we've got 500 here. There's always a gap between them. So that'll help us out when we start, because we don't want multiple people to be infected straight away. We want them to move around and infect each other. So yeah, that has worked. So they're all generated at least a little bit apart. Some of them are very close, but they're not actually touching. And just to prove that they were touching before and they're not touching now, we'll comment some of this code out so you can see it working. So we'll comment out this for loop, and this for loop was the thing preventing those collisions. So we'll comment that out and run it again. We'll see those collisions, those overlaps. Yeah, there's multiple ones there, and if we stick 500 in there, yeah, there's loads of overlapping going on. Lots and lots of overlapping. People already touching, which you could say is good for the simulation, but we're going to start them off separate. So if I uncomment that, so we're checking every person that we try and add against all the other people that we've already added, and we'll end up with our people not touching initially. And we can use the collision methods that we've used there to help us with our infection next time. So there's always gaps between them, and it makes some nice patterns. That's it for now.